All right, hi guys. So last class you learned about the states of matter. There are three. There are solids, liquids, and gases. Today you are going to learn about how each state transitions into the next state. This is called phase changes, okay? There are three states of matter and they go through phase changes. So when a solid turns into a liquid, that's a phase change. When a liquid turns into a gas, that's a phase change. And then you're going to also learn the reverse. Gas going into a liquid and then liquid turning into a solid. Okay? All right. Just before we dive back on in to our phase changes, I do want to quickly review your intermolecular forces. Sorry guys, I'm feeling a little under the weather, so my voice is kind of strange. Because these intermolecular forces is what makes our solids, our liquids, and our gases. All right, so remember, for solids, IMFs are strong. For liquids, our IMFs were medium. And for our gases, our IMFs were weak or non-existent. Okay, so again, just London dispersion forces is an intermolecular force, and it occurs for all molecules. Okay, and it is the weakest. Okay, all right, and honestly, don't care about those two. All I want you to know is that it's for all molecules and it's the weakest. Oh, I guess, and it's temporary. Okay. Dipole-dipole forces happen for polar molecules. It's the medium strength. Okay. And again, a dipole is when it's this guy. This is a dipole. Okay, this is the negative side. This is the positive side. All right. Okay. And then hydrogen bonding is when hydrogen is bonded to oxygen, when hydrogen is bonded to nitrogen, and when hydrogen is bonded to fluorine. Okay, this is the strongest. Okay. And for all intermolecular forces, it is a force of attraction. Not a bond. Please know this because this will be a question on your exam, your midterm. All right. Okay, so let's dive into today. Phase changes and intermolecular forces. So if we just look at these pictures real quickly, we see our solids, they are close together. Our liquids are a little bit more flexible, and our gases are not attracted at all. This is strong. IMF, and this is weak. Okay, when I go from a solid to a liquid, I melt. When I go from a liquid to a gas, I evaporate. Okay, so that means I can have, from a solid to a liquid, I will have a melting point. Nash, stop. Thank you. I will have a melting point, and when I go from a liquid to a gas, I'll have a boiling point. We also know that my solids are cold and that my gases are hot. This means that there is an increase in temp. Okay? When there's an increase in temp, the molecules actually absorb the energy. So these guys, so my gases are fast and my solids are slow. Okay? So as energy or heat is increased, the intermolecular force will weaken. The intermolecular force, the IMF, will weaken. Okay, which is why you're able to go from a solid to a liquid to a gas. All right, so as the energy or heat is increased, the intermolecular force will weaken. Okay, it kind of breaks that attraction. Breaks apart the attraction. Okay. All right. Now let's go the reverse direction. So again, we know that my solids are cold. We know that they are slow, but they have strong IMFs. We know that my gases are fast. They are hot, but they have weak. Okay. When I go the reverse direction from a gas to a liquid, it's condensation. They condense. Okay. And when I go from a liquid to a solid, it's freezing. Okay. When we go the reverse direction, the temperature is decreasing. Which means that the molecules are releasing the energy. Okay? And as the temperature gets colder, the intermolecular forces, the IMFs, get stronger. Okay? All right. That is it. Nice job. Now, your next task for this class is to go to this link and go through there's three stations. You can do them at your desk, all right, but you need to go through each one. Okay, thanks guys. Keep up the good work.